Let me now show you how individual D2000 processes work together. The core of D2000 is D2000 kernel. When it is started, it reads the configuration from the configuration database and holds it in memory. It sends other processes the part of configuration they need. It also handles the log database, which contains logs of various events in the system. There are three basic groups of processes in a D2000 system. The runtime processes run in the background. They don't have user interfaces. They are either started by the kernel or as Windows or Linux services, mostly if they run on a different computer. Every runtime process takes care of some D2000 objects. We say that the process is a parent of these objects. The configuration processes are used to make changes to configuration by system developers or administrators. User processes are run by ordinary users. So, what are the runtime processes? D2000 COM process handles real-time communication. D2000 Alarm handles alarm objects. D2000 Archive is our historian, which stores the data into SQL database. D2000 Calc handles evaluated tags and calculates their values. D2000 DB Manager handles connectivity to external ODBC databases, SQL databases via ODBC interface, or in case of Oracle, via OCI interface, Oracle Client Interface. It supports transactions and is optimized for parallel usage. D2000 Event runs server-side scripts written in Java or in our own ESL event script language. D2000 SAS server is an auxiliary process which is usually run in a demilitarized zone and handles connectivity of processes from less trusted networks. It can, for example, deny login to configuration processes to CNF or graphic editor, or deny control actions from user processes. So, these were the runtime processes. Now, let's move to configuration processes you'll be using for application development. Graphic editor is useful for editing screens. We call them pictures in D2000 and other graphical objects. Configurator tool is used for editing of non-graphical objects. System console is a useful tool for management of D2000 application or applications on a network. It can display redundant groups, connect to individual D2000 servers, display their processes and messages that they write to log files. You can use it to start and stop processes, send them various commands, and activate various debugging categories. As for user processes, a D2000 human interface is our FAT client, which is used by ordinary users. Smart Web and Think client is our web-based technology which can display schemes in a web browser, and also it can be used to program dashboards with responsive design, which are more suitable if you need to get your data to users with tablets or phones which have different sized screens. Our D2000 workbook is a plugin for Excel which provides access to both real-time data and archive values. And then there are interface processes. You can use D2000 Gateway to connect two or more D2000 applications, even if they run different versions of D2000. D2000 Azure IoT Connector is a new thing that handles connectivity to Microsoft Azure IoT platform. D2000 Web Services implements connectivity to D2000 via REST interface and Comet API. For example, you can read current values of objects, read the historical values from the archive database, call a procedure implemented in D2000 event. There are also other processes I've not shown here. There are OPC server, OPC UA server, there is the application manager, which we will be using in a short while to create an application. And there are also others. What's important, there can be multiple processes of any kind. We have applications with more than 20 communication processes or more than 20 event processes, some of them running also remotely. So this was architecture of a single D2000 server. Now before we get to creating the application, let me show you a few screenshots and photos from our applications. This is a simple simulation, part of a demo available when you install D2000, displayed in a human interface. The same screen in a web browser. This is a simple web dashboard with responsive design. A small home automation application displaying temperature in several rooms, energy consumption, and a scheme with a heat pump. Here you can see a few screenshots from a control system displaying overview of energy production in several power plants, that is coal, nuclear, and water, plus some graphs. Again, screenshots from a control system with a slightly upgraded design. This is a manufacturing enterprise system with dozens of users connected to previously shown control system via D2000 gateway. You can see some examples of graphs. This is a production planning application. On the right you can see an additive graph where values of individual objects are added on top of each other. This one is from an energy trading application. So this is the application without any measured points, there are no I/O tags. It's a purely database-oriented application, so no communication process is running there, but several DB manager processes and event processes. The right screen in the background shows OTE data, that is the operator of trading with electricity, which is a Czech energy trading organization. This is a SCADA for combined heat and power generation in a chemical factory. This is a scheme for heating plant containing hot water boilers, cogenerator, production planning, energy balances. The screenshot is from our development server, therefore the values are invalid. On the right side you can see some list of alarms and events. The same application, combined heat and power generation. This is an old screenshot from 2003, an application which controls transit gas pipeline from Ukraine through Slovakia to Czech Republic and Austria. Here you can see an example of XY graphs. The displayed compressor characteristics have data stored in an SQL database. This photo shows a part of a control room of electricity producer. On the right there is a 4-segment barcode display, this unit, plus a 3-monitor operator workstation, both displaying the SCADA system. On the left, behind the glass screen, there is an energy trading room, again a 4-segment barcode display. This time it shows values from a MES system. And another customer with a 6-panel barcode display unit, so the human interface displayed here with multiple graphs is using 6 monitors in Windows. Well, this is the end of my presentation. However, I sincerely hope it is not an end of your work with EPES of the D2000 system. Quite the opposite, it should be the beginning of your exploration of the D2000 system. Please bear in mind that what I showed you today is just a small fragment of the D2000 capabilities. So don't hesitate to use our online documentation, and if you can't find the answer here, you can contact us via email or ask on our community forum.